I'm Susan Crumdyke, and I'm going to present what I hope will be an interesting case study in transition engineering. The project was to investigate and give recommendations to the government of New Zealand on the long-term supply chain strategy. This work was done with Patricio Gallardo at the Transition Engineering Lab at University of Canterbury, and I am currently at the Heriot-Watt University Transition Lab in Scotland. The supply chain study was a ministerial expert working group. So the group was experts in freight, logistics, politics, shipping, and economics, and myself in transition engineering. We worked for about a year and a half and produced a cabinet paper to provide advice to the government on a 40-year investment and policy strategy. The remit was to produce an efficient freight supply chain and to get to net zero carbon, so to follow the policy of the government, and to identify what the critical investments are in the next 5 years to achieve the strategy. The work was done with the Transition Engineering Group at University of Canterbury in the way that I'll describe from here on. In case you don't know where New Zealand is, it is at the other end of the planet, and no, it's not part of Australia. In fact, it's quite a ways, more than 2,500 kilometers from Australia. The Upper North Island is the part indicated here. It's just the long stringy tip of New Zealand, but it is where more than half the population lives. And you can see that New Zealand is completely dependent on shipping supply chains to connect its economy with that of the rest of the world. The closer view of this part of New Zealand shows that there's a deep water port in the north called Northport, very inventive. In the middle of the Upper North Island is the city of Auckland. This is not the capital city, but it is by far the biggest city. Almost 2 million people live in this geographically challenged location for a city, which has its own port. So there's a urban port here. And then there's a big deep water port at the lower end of this area called Tauranga. All right, fun words for everyone. What we do need to note is that the mode share for freight is about 85% road. The roads in New Zealand are narrow. They don't have good shoulders. Very little of the road is divided. The highways have steep grades and tight curves. But despite that, the highest mode share is definitely road. The 3 ports are not operated in collaboration. They are actually set up to be in competition. Now you saw the geographic distance. We will also see that that is a slight problem in the personalities that arise in the operation of these ports for competition. It's very difficult to have simple things that could improve efficiency put through because of the worry that it might favor one port over another. The freight comes in and goes to an inland depot, and that's where the trucks have to take the imports from the ports to the depot and then distribute it around the land. There is some rail in New Zealand. It is, some of it, especially in the far north, is very old, almost 150 years old, and in need of major investment. The exports. The exports come from the land in New Zealand. It's an agrarian economy. One of the biggest exports of bulk in kilotons, as you can see, is logs. That mostly goes out of Tauranga, but also the North Port. And of course, you don't drag logs into the city of Auckland, thank goodness, and try to export those. The exports of other goods include dairy products, so that's mostly dried milk powder, paper and wood products, and produce. So you might have had a kiwi fruit, or New Zealand apples, or New Zealand frozen lamb, or butter. That all comes out of our ports, mostly Tauranga. All right, that is not a surprise. The imports. The imports mostly are heading for the demand centers in Auckland. The import at Northport is basically oil. That's about all that comes in through Northport. But that oil then is distributed throughout the whole rest of New Zealand. And interesting to see that the largest commodity movement in New Zealand is oil. And all of it is imported. A bit of food is imported, and we see that Auckland is a big import port, which makes some kind of sense because that's where the biggest demand is. One of the larger items imported into Auckland is cars. That's where all the cars come into Auckland. Tauranga also has containerized imports, but those mostly end up back in Auckland, where most of the demand is. There is an inefficient imbalance because of the different things coming and going from the ports. The empties, the empty containers, the empty reefers end up in the wrong place and have to then be driven to the other ports so they can be used again. The other problem with the current and future supply chain in New Zealand is that Auckland is an urban port. If you're familiar with freight, you'll know that urban ports, many of them, have undergone big changes. Several centuries ago, those ports were also manufacturing areas, were also warehouse areas. They were very industrial areas. But over time, those activities moved, and also the ports moved. That's most major cities like Sydney doesn't have the port in Sydney anymore. And so the question here is, when we look at the city of Auckland, is this one of those cities that would actually be better off redeveloping its port area as central business district? The CBD of Auckland is very constrained in land, mostly because it's so integrated with the water. And there's also, I think it's 50 some extinct volcanoes, so very steep hills that you can't really develop on. And so the land represented by the port is an awful lot of potential development land. In previous era, another area of the wharf was redeveloped into CBD, and that has become very valuable property indeed. It isn't just the waterside port area either, though. It is the adjacent staging area for the trucks and the train. And the fact that the trucks get all backed up in the traffic here trying to get on the port, and that as they leave the port, they have to pull a very steep hill, which leads to a lot of noise and air pollution as the cold diesel trucks pull themselves up a hill. Auckland competing with the other ports just doesn't seem to make sense. It's inefficient to try to move that much of the country's freight task through the middle of the country's biggest city, to get outside of the city, to get to the hub where the freight can be broken down and put back onto trucks to be shipped around to where it needs to go. So this question looms large in the long-term decision. We applied the processes of transition engineering to this question. I have to say that there really didn't seem to be solutions. This working group was actually doing the 21st study of the ports and the freight supply chain of the Upper North Island. Study after study would just bounce around with different solutions. And so we, in the research center, applied the transition engineering approach. And we want to answer these questions, not what is the solution, but how do we actually do what we need to do? And so therefore we use engineering approaches. The method then is to just design what would work. And so in 2060, taken that the freight movements by truck are going to be extremely problematic in 2060 with a net zero achievement, then we are looking for how to have thriving hinterlands where produce is produced and needs to get to demand centers and export. And what we see is that the renewable energy profile of New Zealand is very good. And so what we see in 2060 is a well-operating national electric rail system, a rail network that serves passengers and freight. And we see that we have more of a cooperative model between the ports. We have a balance of import and export at the deep water ports. And we have 80% of the freight is moving by that rail and by coastal shipping. And that's how we actually get to the net zero requirement. What we also see is that there's now 3 hubs and big hubs at the other 2 ports so that the bulk can be staged for export and that the imports can be shipped to the outside of Auckland instead of to the inside of Auckland, and then repackaged and distributed back outside of Auckland. So well-placed ports, interconnected with rail, and that would work. How do we know that it would work? Well, we used digital twin simulations of the rail and port network. And we put today's freight task through that system using the digital twin and agent-based simulation. And that, of course, is AnyLogic is what we used. The ports would be used differently than they are today, especially North Port, which would be greatly expanded and would have to take many more ships than it is today. And so the question of could it do that was answered simply by using the agent-based simulation. The freight rail is going to be a very large expense. And so the understanding of how the freight rail and the hubs and the ports can work together in the most efficient way and reduce the need for truck trips to only 20% of today, so that something like electric road or biofuels could serve. That we had to do by modeling the freight task through the infrastructure. So the infrastructure solution, I guess you'd call it a solution, what would work is connection to the ports. It turns out that the North Port currently is not connected. So that would be the first expenditure for the government right now directly, is to get Northport connected by rail. And also the North Auckland line is in disrepair. It's very old and it needs to be rebuilt. So in conclusion, the future of New Zealand's economy completely depends on building of electrified rail well connected to ports and hubs. Today's political indecision and competition is really irrelevant by the time you get to 2060, and today's infrastructure decisions are critical to achieve that future economic vitality. And so seeing what would work and just building it was the conclusion that we got from the transition engineering, and what was in fact tested out by EY to be by far the highest benefit cost ratio, and which was presented in the cabinet paper to government. Thank you for listening.